welcome to CEC lectures. Myself Dr. Preeti Tikwani from Department of Computer Science, Arabic College, University of Delhi. So in this series of programming in Java, in our previous lecture we have seen the concepts of bytecode and platform independency. And in today's lecture we are going to cover the paradigm on which the Java language is based, and that is nothing but object-oriented programming paradigm. So in order to understand that paradigm, let us see, how a program is actually built. So program, when we talk about, is going to consist of, two elements. One is the code and another one is data. So there can be two concepts when we talk about these two, elements. One is code, another one is data. That code says, what is happening, and data says who is being affected. So code is what is going to happen in the program, that is what the code is, and the entity which is going to be affected by those happenings is actually the data. So these two terms, one is what is happening and another one is who is being affected, is going to, we can say, form the basis for two paradigms, and these two paradigms are actually named as process oriented model and object oriented model, or we can say, structured programming and object oriented programming. So these two paradigms are going to govern how a program is being constructed. Now these are the two approaches in which we are going to code the program. When we talk about the procedural languages such as C, this is going to employ the model which is the process oriented model, or we can say it is related to structured programming, in which this approach actually characterizes a program as a series of linear steps. So this is focusing on code, and the process oriented model can be thought of a code acting on data. So here the primary element, or the element on which we are focusing, is the code, and that code is acting on data. This is what the approach of your process oriented model is. Now this can also be seen by, we can say, in a different way, which is known as, structured programming. So when we talk about structured programming, we have various functions, and your program is actually divided into these functions and modules, and every module or every function is having its own data, and and also the code which can be called by other modules. So here is a we can say figure which is showing the concept of structured programming. In this structured programming concept, we have one main program which is going to access, or which is able to access the global data, and we have other modules of the program which are let's say module 1, module 2, module 3, module 4 and module 5. All these modules are having their own functions, and they can also use their own data as well as the global data too, and the main program is also going to use the global data. So this is what the we can say structure of or this is what the basic concept behind the structured programming is. So a main program having different modules, those modules are having their own function and the data as well, and different functions can share different modules can share the functions among themselves, and global data, being global, can be used by the main program as well as it can be used by all of the functions. So this is what how structured programming is going to behave. So basically it revolves around the code. Now when we talk about this structured programming, it is very difficult to manage this when the complexity or the size of the program is going to be increased, and today's the applications which are being structured or which are being used today are huge applications with high level of complexity. So with increasing complexity, this structured programming approach structured programming approach will be very difficult to handle. So in order to manage that complexity, the second approach, which is object oriented programming paradigm, was actually we can say conceived. This object oriented programming paradigm organizes a program around its data, not around the code, and this data is actually here is in the form of objects, and we have around for those objects we have a set of well defined interfaces in order to access that data. So object oriented programming can be characterized as the data controlling access to code. So here your data is actually the main or the focused entity, it is not the code, and by switching the controlling entity to the data, several organizational benefits can be achieved when we are talking about uh, uh, programming a particular application or programming a particular system, because the data should be at the center place, or data should be at the core, we can say. So data here is actually coded, or is actually termed, we can say is actually we can say bundled in the form of objects, and these objects are having both the things, one is the data and another one is the method. So data actually uh, is something which is the which is related to the attribute of an object, and methods are the small modules or small functions which are going to operate on that particular data. And these objects are generated through a blueprint, and that blueprint is nothing but the class. Objects of the same class have the same data elements and methods, same data elements and methods, and objects are going to send and receive the messages in order to invoke the uh, actions. So I'll be covering objects and classes in in a greater detail in my upcoming slides. But when we talk about the key idea in object oriented paradigm, object oriented programming paradigm, we can say that the real world can be accurately described as a collection of objects that interact with uh, either with each other or with the environment, and that is what the key the key concept in object oriented programming paradigm, which says that the whole code should revolve around the data, and this data will be represented in the form of objects. And when we talk about modeling the real world, that real world can be very precisely and accurately modeled as a collection of objects, and these objects will interact with each other. So in order to understand this whole concept, let us have a look at the figure which is going to describe the structure of the object oriented programming paradigm. So in this paradigm, you have on the screen there are three objects which are shown with the help of I can say ovals, and there are object 1, object 2 and object 3, and these object 1, object 2 and object 3 are having data. So object 1 is having its own data as well as its own functions. Similarly, object 2 is having its data and the functions, and so is your object 3 is having its own data and functions, and these objects can interact with each other, and this interaction is shown here in the form of arrows, we can say. So when we go into deeper details of object oriented principles, what are the key concept which comes under this paradigm? the key concept of object oriented programming are objects and classes, then we have encapsulation, then we have methods and variables. Inheritance is also a very important principle of object oriented programming paradigm, and then we have message passing and polymorphism. So apart from objects and classes, encapsulation, abstraction, inheritance and polymorphism are something which are known as the fundamental principles of object oriented programming paradigm. So when we talk about object, basically any real world entity which can be modeled, that is an object, and whenever we need an action to be performed by an object, that is going to be coded into into a method. Now description of objects, when we talk about, is having it can be modeled with the help of attributes, and a category of similar objects such as automobiles can be described as a class, but the class does not hold any value of the object's attribute. Now in order to understand this whole concept, let us take an example of a car. So car actually is a real world entity, and this real world entity can be modeled in the form of an object. Now what all could be the attributes of this car? It could have a color, then it could have an engine capacity, then it could have a we can say a seating capacity, and the model thing. All these attributes, all these descriptions of the objects are known as uh, are modeled as the attribute. Now let's say this car is actually doing something as in, like a verb is being performed and action is being performed by an object. That action of running or applying brakes are these these are the examples of two methods for which we need to code the data. So we have an object that could be a person, place or thing, any real world entity. In order to describe that real world entity, we have attributes, and in order to code the action performed by those objects, we have methods. When we talk about the term class, so class is actually a category of similar objects. So for example, I am talking about car here. So car is actually an any car. Let's say for example I am talking about Tata, or I am talking about Maruti. They can be the objects of the class car. So the car is actually a class here, and various different objects, for example Maruti, or Tata or Hyundai or whatever. All these are actually uh, we can say objects. So because all these objects can belong to the class car, the model here is the different, and obviously attributes can be attributes can vary. So this was actually objects and classes. When we talk about objects, in order to model a real world the entity or the concept or even the process, we use objects, and the blueprint from which the objects are created is actually your class, we can say. And classes and objects are the basic building blocks of object oriented programming paradigm. Then class, as I have told you, is a set of variables which is used to represent the attributes and functions. uh, Attributes are actually the we can say uh, properties of the object, and there are also the functions which are required in order to describe the behavior of the object, and that those functions are going to perform something, or that those functions are going to act on the variables. And objects is actually an instance of the class. Class is actually the blueprints of the object. Class does not hold any value in its variable, while object will hold value init variables. The data here can be accessed by the functions, and the instance of the class that holds value in variables whose data can be accessed by function is actually your object. Now when we talk about, we have seen two paradigms. We are yet to see other properties of object oriented programming paradigm, but we have seen two paradigms. One is the process oriented model, or we can say the structured programming thing, and another one is the object oriented programming thing. Now how, why do we need this object oriented programming thing? Because there are several reasons when we talk about the advantages or what is the need of object oriented programming paradigm. First of all, uh, we can model the real world very efficiently in this object oriented programming paradigm, and this is a way which is far more efficient as compared to our the structured programming paradigm. It is also going to save the development time and hence the cost by reusing the code. Once an object is created, it can be used, and once an object class is created, or simply we can say once a class is created, it can be used in other applications as well. In object oriented programming paradigm, the debugging facility is easy as compared to the structured programming. Classes here can be tested independently, and reused objects have already been tested along with these classes. So object oriented programming, when we talk about, they are going to save the development time and cost. Reusability is there, debugging is easy, and classes can be tested independently. So yes, we can say there are several advantages of this object oriented programming paradigm. So in this lecture, what we have compared till now is the structured programming, which is based on the different modules accessing the similar global data, and their own data is your structured programming. When we talk about the object oriented programming concept, this can be modeled in the form of objects and classes. But apart from objects and classes, some very basic elements of object oriented programming paradigm are there, and let us see them one by one. So one, first of them is encapsulation. Encapsulations is also known as data hiding. So when we talk about encapsulation, that means technically we can say making a capsule of data and functions. So that's why it is known as data hiding, because we are encapsulating data in a wrapper, we can say. So that is in the form of an object, and only objects methods can modify the information within the object. So please recall the figure of which this object oriented programming paradigm which we have just seen, and it is shown on the screen. So here in an object, the data and function are actually we can say bundled up, and this bundling is nothing but your encapsulation is, in which the data and functions are bundled together, and in order to operate on that particular data, we need functions. So this is what encapsulation is, and this is going to this is required to achieve the data hiding thing, because here only the method of the particular object can modify the information in the object thing. So this is a mechanism by which we are going to combine the data and the functions that manipulate the data into one unit, and this encapsulation is being enforced with the help of the concept of objects. Now when we talk about the next concept, which is abstraction, so abstraction says we need to focus only on the important facts about the problem at hand. So for example, we have just seen the example of car. So when we talk about, the car as an object, we actually, or when we talk about the car as an object, and there is a method which is going to describe about the, driving. So driving is something which someone can perform without knowing the inner level details of any, design of the car, or any, kind of other inner level details. So when we are going to drive the car, we just what we are, aware of is just the interface, that is the steering and the, gear thing, and then the controls at feet. How these controls, are coordinating, and how it is going to, run that car, that all those are actually details which are not, which we need not to focus. So the abstraction says we need to focus only on the important facts about the problem which is we are going to have. So when we are going to drive a car, we don't need to know about the, how this, the petrol and air are mixed, how this is ignited. So what we need to do is just to use the controls. So basically we are extracting the essential properties and behaviors of entity, and this is what we call is abstraction. And classes represent such an abstraction, and classes are more commonly referred as, abstract data types. Then we have one, fundamental principle of object oriented programming is polymorphism. Polymorphism, when seen as a term, morph means form and poly means many. So one function can be used in many of the forms depending upon the argument passed to it. So operation of one function will depend on the argument passed to it, and this is what, we can also say the same word or the phrase can mean, different things in different contexts. So for example, I am talking about sum, the function sum. When I am going to give two integers to this sum, it is going to add those two integers. But if I am going to give, let's say two strings to these, the function sum, it is going to, concatenate it. So depending upon what data I am going to pass, it is going to, behave differently. This is what is called polymorphism. And the another concept which is there is about the inheritance, which is a way of organizing the classes. So classes with properties or with common properties can be grouped so that those common properties are defined only once. So here we are going to have, as the term indicates inheritance, we are going to have here the superclass as well as the subclass. So for example, we have one superclass, let's say automobile, then the subclass to that automobile is the, car. So superclass is going to have some attributes and methods, and these attributes and methods are given to its subclasses. So that means superclass is going to inherit its attributes and methods to subclasses, and subclasses can inherit all the attributes and methods from the superclasses besides having its own attributes and methods. So car will be having its own attributes and methods, but apart from that it can have some methods which are which it can inherit from its superclass or its parent class, which is automobile. So here in this lecture we have seen different elements of object oriented programming paradigm, and we have also, we can say, compared the structured programming as well as the object oriented programming thing. Here is a list of references which is being used for preparation of lecture. Hope you have enjoyed one. I'll see you in the next lecture. Till then, take care. Goodbye.